Hello! In our last video we took a look at shifting elements in an array, and specifically we imagined that we had an array of people sitting here at the movies, and actually I'll write it this way this time: Al, Bo, Psi, and Die. And we imagined someone came up here on the left hand side and everyone had to shift down to make room for them, and the last element fell out of the rightmost end. This time let's try it the other way around. Let's have everyone shift to the left. So we're going to imagine Ed here, who was the person who fell out in our last video. Ed is pretty ticked off about this, and so Ed has decided to get mad here and sit down where Die was. And therefore all of these people here, Bo, Psi, and Die, who just moved down in the one direction, they're now going to move back down to the left. And Al over here is going to fall out, get removed from the left-hand side. So that's the plan. Bo, Psi, and Die shift to the left. Al gets removed. Ed can now sit in seat 3. So when we take a look at the sequence of events here, the easiest way to write this program is going to be to remove Al first from my array. So we'll remove Al. And then having removed Al, we'll shift Bo, Psi, and Die to the left, and that's the part of this that we're going to spend the most time thinking about. But Bo, Psi, and Die shift to the left over one seat, and now there's room for Ed, so Ed can sit, and Ed's going to sit in seat 3 in this particular example. And of course we never want to confuse the fact that I'm showing you a particular example of the problem, but that this program that we're going to write should work for any length array with any people in it. And the key operation here, of course, was shifting Bo, Psi, and Die to the left. And when we want to shift Bo, Psi, and Die to the left, we want to think about who should move first. Who moves first? Where do they move? From where to where? Who moves last? Where do they move? From which index to which index? And there are a number of ways that we could do that, but I think far and away the easiest way is going to be if we think of Bo moving once Al has been removed. Al's already been removed here. Bo, here, let's remove Al. There we go. Al is gone. Very sad. Al's been removed. Now Bo can shift into the seat that's been vacated by Al. So the first move is going to go from index, Bo is at index 1, and moves to index 0. Now Psi can move from 2 to 1. Psi moves from index 2 to 1. And finally, Die over here can move from index 3 to 2. Die moves from 3 to 2. And now Ed is triumphant. Ed can sit down here in seat 3 where he wanted to be all along, where he started at the beginning of our first shifting video. Alright, so this chart here is going to dictate how our program's going to go. Apparently, we have two choices when we write this loop to shift these elements, and we'll use a for loop to do that because I think that's the most straightforward way of implementing this program. When we use that for loop, this is going to be our index. Either we will choose these 3 indexes, we'll have our loop go through these values, and our index will be from, or our loop will go through these values here, and our index will be 2. And the suggestion in a previous video was to actually call the loop index from or to, so that you can remember whether your loop index refers to the seat we're moving from, or the seat or array position in general that we're moving into. And the number one mistake that we can make in a problem like this is losing track of whether our loop variable meant the seat we're moving from or to. So just a good variable name here will go a very long way. So let's write this program now. So I wish we could see all of this at once, but let's go with this. Alright, let's do this the old-fashioned way. We'll just remove that brace with the eraser. Alright, so I'm shifting left. So all of these people are moving to the left, and the first step was to remove Al. In other words, remove the person in seat 0. That's no problem. We'll just take, person in seat 0, and when we remove them, we're supposed to return the person that was removed. So we're going to make a note of who was removed. We will save that person in a variable of type person, since my array contains person objects. We'll save them in a variable called removed, since they're the person I removed. And we'll continue. Now we have the shifting Bo, Psi, and Die, or whoever happens to be in the middle, one seat to the left. So we need a loop, and we get a choice of loop variables, from or to, and I'm going to pick from. We'll see this again with to in a moment. And we ask ourselves, what should from start out being? Well, from should start out as 1, according to our chart, so we'll write 1. Of course, you may be solving problems with shifting where you don't start shifting from 1, so it depends on the particular problem. We'll shift from 1, and then what's the limit? What's the last element that from, the last index that from should be? 3. And where did 3 come from? Because 3 is the last index. So from is going to go all the way up to the last index, so that we move first from 1, then 2, then eventually the last index. So from goes up to and including, so less than or equal to, my last index. And my last index is people.length minus 1. Remember, the last index of an array that starts at index 0 is always the length of the array minus 1. And I have a couple choices of how to write this. Some people might prefer making this strictly less than the length, which will also work fine. Either way is fine. Let's go back to the way we first had this. Okay, now, what happens to from as we loop? It's counting up. 1, 2, 3, we're counting up. So we'll increment from. And then inside the loop, we're going to take a person at one position and store them away at some other position. So we'll take the person at from and store them away in, let's see, what do we do with the person at from? See how much easier this chart makes our life and these pictures? So I strongly recommend draw these little charts, work through an example, draw pictures whenever you're working on a problem like this, or pretty much any problem. So the element at from always moves to 1 less than from. 1 becomes 0, 2 moves to 1, 3 becomes 2. So always move to 1 less than from. That's from minus 1. And then when I'm all done, let's see, person P, who in my example was Ed over here, P can sit in the rightmost seat now, so P can sit at the rightmost seat. That's the last index, which is people.length minus 1. And I can now return the person I've saved all along who got thrown out of the row, and that being Al, who was in position 0 before. Alright, that wasn't too bad. Let's take a look at what's tricky about that. We had to know to start at 1. We had to make sure that our variable was less than or equal to the last length. We had to remember that we increment as opposed to when we shifted right and we decremented. So even though everyone's moving left, the wave of movement is moving to the right. Psi moves, then Di moves, then Ed. The wave is moving to the right. The indexes are increasing even as people move to the left to decreased index. And we needed to make sure we put from here and from minus 1 here. So again, 5 places we could easily be off by 1, reverse adding versus with subtracting, and end up with a program that isn't going to work at all and is going to be absolutely miserable to track down our mistakes. So we really want to reason very careful and be very confident in what we write before we wrap up this method. Alright, speaking of wrapping up, let's wrap up this whole session by finishing this off. Let's shift in the other direction. So suppose here's the version where we use from. In fact, it's really only this part of the code that's going to change. So here's what happened when we used from. Now I want to try the same code, but this time using to. So our method, I'm implementing the exact same method. This is the same method all over again. I'm still removing the person at 0. I'm still trying to solve the exact same problem. In the end, I'm still going to put a person in the last position and return whoever it is I removed. And in the middle, I'm still going to have my for loop, but this time I want to get some practice using the loop variable to, to. So I'll keep track of where I'm moving to this time, but I'm still shifting left, same algorithm. So which position do I move to first? Well, I move to 0. I can see that from my chart. Thank God for the chart. Move to position 0 first. It occurs to me I probably meant to declare this variable as an integer. Oops. Okay, move to position 0, and what happens to 2? Well, 2 increases. So what's the last value of 2? It's the number 2. And where did the number 2 come from? It came from the second to last index. The second to last element second to last position is the last place I move into, and that's where the last element moves into the second to last position. So the second to last position, that is, and I'm going up to and including the second to last position. Since the last position is index length minus 1, the second to last index is in length minus 2. Sorry, excuse me. And let's see, 2 is going to increment, right? 0, 1, 2, I'm increasing my loop variable. And I'm copying an element, and I'm not sure yet where I'm moving them from, but I know they're going to my 2 index. So where do they move from? Well, relative to 2, from is always 1 higher. They're always moving from my 2 index plus 1. So my 2 index plus 1. So this is another way we could write the exact same program. It does the exact same thing, but all we did was change whether we used the loop variable from, or we used the loop variable to. But notice how everything changes. Where I start, where I end, I still do increment, but where I copy from and to, these expressions look very different, even though in practice, when I actually run the program, they're going to do the same thing. So hopefully that answered some of your questions about shifting elements in an array. And remember, the real key is, I think, make these charts for yourself, commit to just one of these indexes to being your loop index, and use a good name for that loop index, and ask yourself questions like, who moves first, where do they move, who moves last, and from and to, where do they move? I'll see you later.